Hello, in this video I'm going to differentiate nominal rate NR and the effective rate ER. And here I have different interest rates compounded differently. So you have monthly, quarterly, semi-annually, annually, and then you can also do daily, weekly, etc. The rates that you can see here, 5, 6, 7, 8, these are the nominal rates. In problems, you are mostly given the nominal rates, not the effective rates, because the effective rates have to be computed. You will be converting all interest compounded something except annually to interest compounded annually. So meaning, you can convert this one, and this one. For 8% compounded annually, you don't need to convert this anymore because this is already compounded annually. Meaning to say, this 8% right here is also the effective rate. Now, how about for the other compounding periods? Because what will happen is you will convert them to a rate, whatever rate you get here, using a formula, and all of them will be compounded annually. And the rates right here are your effective rates. Again, for compounded annually, you don't need to convert it anymore because it's already compounded annually. So meaning, this one, 8% compounded annually, 8% is nominal rate, that is also the effective rate. Now, given the compounding periods here, compounded monthly, quarterly, semi-annually, how do you convert that to percentage compounded annually? We have a formula. The effective rate is computed by getting the sum of 1 and a fraction with the nominal rate as the numerator and the number of compounding periods as the denominator. You will raise that by the number of compounding periods and then minus 1. This is the formula to compute the effective rate given the nominal rate. So let's try using this one with 5% compounded monthly. So 1 plus, the nominal rate is 5%, right? So 0.05 compounded monthly. So if the interest is compounded monthly, the number of compounding periods is 12. And raise that to 12 minus 1. The answer here is 0.051162. Let's convert it to percentage. It's 5.1162%. This is the effective rate. This is the compounded annually version of the compounded monthly version from earlier. To appreciate, let's apply using both the nominal rate and the effective rate given other variables as fixed. So let's have two cases here, case 1 and then case 2. For both cases, let's give them a principal of 1,000 and time of 2 years. And then for the rate, let's first use the nominal version, 5% compounded monthly. So I'll just write CM for compounded monthly. And then for case 2, we'll use the annual version. It's 5.1162% compounded annually already because that's effective rate. Now, given this, let's compute in both cases the future value. Then I will also write the formula for those who forgot it. So get your present value, 1 plus rate divided by number of compounding periods raised to number of compounding periods times time. And then let me just copy. Let's compute. Present value is 1,000. 1 plus. Your rate is 5% compounded monthly. So number of compounding periods, 12. Raised to 12 times 2. That's 2 years. The answer is 1,104.94. Now let's try this one. Present value is 1,000. 1 plus. Your effective rate is 0.05 1162. And since this is the annual version, compounded annually, 1 raised to 1 times number of years 2. The answer here is 1104.94. So given different rates, one is compounded monthly, one is compounded annually, you are still getting the same future value because you converted the nominal rates properly. Now let's convert another. Let's use the second one, 6% compounded quarterly. Let's convert that. I will write again the formula for effective rate. So let's apply the second one. That's 6% compounded quarterly. Okay. So 1 plus 6%, 0.06, compounded quarterly. Number of compounding periods, 4. Raised to 4 minus 1. Your effective rate is 0.061364. In percentage, it's 6.1364%. This is the effective rate, the compounded annually version of the compounded quarterly earlier. Now let's have again two cases, case 1 and case 2. Under both cases, let's have a future value of 2,000 and time of 3 years. And then for the rate, this one, let's use 6% compounded quarterly. Case 2, we use the annual version, 6.1364%, and this is already compounded annually. And given this, let's compute the present value under both cases. The formula is, you get the future value times 1 plus fraction of your rate as numerator and number of compounding periods as denominator raised to negative number of compounding period times time. So let me just copy that. Now let's use the formula. Future value is 2,000. 1 plus, your rate here is 6%, compounded quarterly, so you use 4. Raised to negative 4 times number of years, 3. The answer here is 1,672.77. And then on the other side, future value also 2,000. 1 plus, use the effective rate, 0.061364 divided by 1. It's 1 because it's already compounded annually. Raised to negative 1 again times number of years, 3. The answer here is 1672.77. And that's the difference between the two. For nominal rate, it will apply to all compounding periods, while for the effective rate, you are converting the different periods into interest compounded annually. You just use the effective rate formula. And that's it for this video.